There are 4 news from Microsoft, Google, and NVIDIA that will blow your mind. And this is just like start of something that we have never seen with AI before. One, first of all, nothing to do with AI at all. Microsoft has released a new chip that is called Majorana 1. This is Microsoft is claiming that world's first quantum processor powered by topological qubits. What they're saying, topological qubit, is a completely new material. So you've got the matter or material, solid, liquid, gas, and Microsoft is claiming that this is none of these three. It's not solid, it's not liquid, it's not gas, and they've built a new material that is specifically for quantum processors. And Microsoft is saying that this gives the ability to scale to 1,000,000 qubit on a single chip. So this is going to be the world's first QPU, quantum processing unit, powered by a topological core, which is what they've completely designed. There is a nature paper, there is a device roadmap, how they are going to build it big, make it big. But for now, if you were to look at the scientific community and then just try to demystify everything that is around there, there is one comment on Hacker News that I found pretty interesting. It says, "I work in the field while all the players are selling a dream right now. This announcement is even more farcical." Majoranists are still trying to get to the point where they have even one qubit that could be said to exist and whose performance could be quantified. The Majorana approach, compared with more mature technologies like superconducting circuits or trapped ions, is a long game where there are theoretical reasons to be optimistic, but where experimental reality is so far behind. It might work in the long run, but we are not there yet. So as much as we can feel really mind blown, happy about this particular news from Microsoft, it has to be something that you have to take it with a pinch of salt, because we have seen multiple quantum computing in news, like from Google, now recently, just like today from Microsoft. So just think that this is a breakthrough, but for it to be materialized or to crack your cryptographic codes, it will take ages, not just today. The next one is also from Microsoft, which is very interesting and more practical. Microsoft has released something called Muse. This is the first generative AI model Microsoft has designed to help with gameplay ideation. So what Microsoft has done is they've taken an Xbox game, which is called Ninja Theories. I think the name of the game here is the Ninja Theories Bleeding Edge game. They've trained a generative AI model that can basically like create whatever that is required for the game. So it can create the gameplay itself. And what Microsoft is saying is that this model that they have created here, which is what they're calling as WAM, a world and human action model. So this is like the model that can understand physics, the model that can understand the rules of the games and then design things according to the rules of the game. It's like Sora, but the next level of Sora, which has like more rules, more boundaries, sticking to whatever the rules that are presented with. So Microsoft is saying that this is going to help in game ideation, gameplay ideation for people who are creating the games. I think the most interesting part is not that there is something like Muse exists, and NVIDIA has been exploring this idea quite a bit at this point. What is more interesting is that Microsoft has released this with a Microsoft license here, but it has released the model. So the model weights are available as open weights. So there is one 200 million parameter model, there is one 1.6 billion parameter model, and there are some instruction about how you can run the model. I think it'll be pretty fascinating to see if we manage to run the model and if we can create an entire gameplay just from a large language model rather than game designers designing a game in itself. The next one is from Google, and this is again very significant research advancement. Google has created something called AI Co-Scientist. What is AI Co-Scientist? It is a multi-agent system that is built with Gemini 2.0. Gemini 2.0 is acting as a virtual scientific collaborator, so to help scientists create novel hypotheses. And not just this is a paper, not just this is a blog post. Google is claiming that they used this AI co-scientist to create some hypothesis. Okay, and they said they went back to those laboratories, labs, and then they validated the idea, and the idea actually worked. For example, drug repurposing for acute myeloid leukemia. So they're saying that we applied AI co-scientists to assist with the prediction of a drug repurposing opportunities, and with our partners validated the predictions through computational biology, expert clinical feedback, and in vitro experiments. Notably, the AI co-scientists proposed novel repurposing candidates for AML, acute myeloid leukemia. Subsequent experiments validated these proposals and confirmed that the suggested drugs inhibit tumor viability at clinically relevant concentrations in multiple AML cell lines. I mean, honestly, like if this is reality, if today you can have an AI co-scientist that can work 24/7, like without any human, involvement, human in the loop, and it can suggest things. It doesn't have to have a breakthrough, but if it can just suggest things, and that can have an impact in the real world without like messing up, without hallucination, I think it is completely insane and then hugely impactful. And they have done this with the 3 different applications: drug repurposing, novel treatment target discovery, explain mechanism of a gene transfer evolution. And if you see the mechanism of how this is designed, so there is some sort of test time compute happening, but this is a bunch of specialized agents, the agents that are focusing on generation agent, reflection agent, ranking agent, evolution agent, proximity agent, and meta review. So all these agents that are like supervised by Gemini 2.0, and then they basically work in loop, in tandem, for a common goal about how do you achieve whatever the goal that has been like given to you, the objective that has been given to you. There are more details on how they've done, how things have improved, how test time scaling has helped. And this is something that I might make a separate video altogether because it's completely mind-blowing. And I think at this point, one thing that I appreciate about Google at this point, or GDM, particularly Google DeepMind, is there is always something attached to biology or physics or something that is closer to real world than just LLM, always happening with Google DeepMind. I think maybe this is because of Demis Hassabis's strong obsession with biology and other things, or maybe like Google has got something going on there. But it's very exciting to see that some large language model that we use to generate some crap slop is also could be helpful at some point to do breakthroughs, scientific breakthroughs that are not just hallucination, that can have a real life impact. And finally, there is a new model from NVIDIA. This is a foundation model, that it means like a pre-trained model for biomolecular sciences. So what this model is going to help with is genomic sequencing. The model is called Evo2. It's a new AI model that is built by NVIDIA DGX. And this is something that they have built with a partnership with Arc Institute and also Stanford University. So this new model is going to help in human genomic sequencing, drug discovery, and a bunch of other things. And this is something that I've been always wondering, like if AI model, or whatever we call as large language model, or autoregressive models that sample from a distribution and then create next best word, next token, if it can do that, why wouldn't it do genomic sequencing, which is like quite important for drug discovery, vaccine discovery, or accelerating clinical trials? Seems like people are doing that, and it is very fascinating to see there is a new model and there is a architecture, and in fact that there is a technical report that goes into detail about how they managed to do this genome modeling and design across all domains of life with Evo2. And there are like a lot of information about all these things happening here, like different organizations coming together and then making this happening. You see a lot of familiar names here. So you've got Greg Brockman. Something that I know, Greg Brockman, obviously from OpenAI, I think, who went on a sabbatical to work on this particular project. Then you have got Arc Institute by Patrick Collison, who is Stripe's CEO and co-founder. These 4 different news, it actually shows like a leap forward, like different frontier, not just like text, something completely different. Quantum computing, video game generation, AI science, and also biomolecular science like genomic decoding. Pretty excited to see these things today morning happening, and let me know what you think about it. See you in another video. Happy prompting.